So what we have up on our screen now is our mission platform. It's the user interface. It puts all the aspects of the mission in one area, so we can look at the mission at a glance. Up on the left, you have the front-facing camera. To the right of that, you have the rear-facing camera. Underneath, you have your map, and the blue line is the waypoint list that we are going to use for today's mission. The waypoint is basically the breadcrumbs or the path that the vehicle would take for a mission. This path has been pre-recorded for this demo. To the right of it, we have the illustration for the LiDAR sensor, and this will become more obvious during our demo. Now, this being said, we'll start the demo to show you how this works. So the first step is to send this waypoint list to the vehicle, and as we get the confirmation from the vehicle that the waypoint list has been sent, we can now go and click our start button. Clicking the start button triggers the vehicle to start its algorithm and starts its checks to make sure it's safe to start and go on a mission. The vehicle goes through the ignition sequence. It goes through ignition off, ignition accessories, or ignition on, just like any of our vehicles that we have nowadays. It also cycles through the transmission gears, so it goes through park, reverse, neutral, and drive. Once the vehicle goes to drive, it will proceed to the mission that we have pre-recorded the path for. For this mission, we've chosen to go roughly about 6-7 kilometers an hour. You can change this using the editor, and we can go through the details of how to do that later on. As the vehicle is moving, you do see the live feed from the two cameras, front and back. You can also monitor the vehicle dashboard, so you can see that the vehicle is going at 8 kilometers an hour, slightly over 8 kilometers an hour. You see the steering angle, the battery level, and the strength of your GPS signal. As you can see on the map that we are approaching a turn, so the vehicle does understand that this is a turn, and its behavior basically slows down the vehicle to make sure it's a safe turning speed and that the vehicle is doing everything it can to make the mission as safe as much as possible. As the vehicle finishes the turn, it will go back to the speed that we've set for the mission. You can see ahead of us there is a fence starting, and we're doing a short portion of it for this demo. So we've chosen one of the waypoints ahead of us. At that point, we have done two things: turning our flag to on for the laser detection, for the fence detection, and turning the laser for it on. And that automatically turns the algorithm to do the checks once it reaches this area. The other thing we've done is slowing down the vehicle, because according to our previous tests, this area of the mission is known to be slippery. So we've set our speed to slow down. So as it finishes this turn, and as it does its checks, the vehicle would make sure everything is safe. It's going at safe speed, and we'll proceed to that speed we've set in our editor. Looking ahead on our waypoint list, you see that there is a loop back. The function of the loop back is that the vehicle can automatically turn around, making sure you can find it at the place where you dropped it off. So as a user, it is a matter of convenience. You can simply just drop the vehicle off at the starting waypoint at the beginning of your mission, and once the vehicle is done and the mission is done, you'll find the vehicle back at the end point. This is convenient because if you need to access the vehicle, you don't need to go to different ends of your facility, or in this case, an airport. So once the vehicle is done with the loop back, it's starting to head back the opposite way. You would see on the LiDAR visualization tool, some pixels would come up. This is basically the snow and dirt pile that we see in front of us. And as long as these pixels are not in the alert zone, then it's fine. It's not a threat to the vehicle. The vehicle still understands it's safe to proceed, and there are no major or immediate threats in front of it. As the vehicle finishes the turn, again, you'll see it goes back to its original mission speed. Now, the other thing I would like to highlight, for these two cameras that we have, you have the capability to move them. So you can move it right, left, up, or down, zoom in, or zoom out. You also have the option to remotely control the vehicle in case the vehicle does come across something that was that was unexpected. And as a user, you have the chance to look around with the cameras, as I mentioned, and take the necessary actions. If these action means that you need to move the vehicle, you can use the remote control section from the user interface, speed up the vehicle, slow it down, turn it around, and change your gears. So you can possibly go to reverse, drive the vehicle back, drive it around an obstacle, and go back, and then resume the mission. You can also use something like the Logitech G9 that we have here, and it's basically a steering system for video games, and it is adapted to work with our system here. Ahead of us we do have an animal cutout, and as soon as this animal gets in the alert zone, the red zone in our LiDAR, we would see that the vehicle detects it as an obstacle, and the vehicle stops, and it keeps log of the animal or the threat in front of us. One of our team members is now moving the animal away. So during your mission, if you do come across something, the vehicle does all the checks necessary, and as soon as the animal or the obstacle leaves, the vehicle returns to the rest of the mission. The vehicle has reached the last waypoint of this mission, that is the end of the mission, and it stops automatically. We have our team member walking towards the vehicle, and now we detect him as a human and an obstacle since he was in the alert zone. Our team member has taken over as a manual user, and he will be driving the vehicle around. So you can see now the vehicle is going in the manual mode, and you can track that the vehicle ignition is on, he's in the drive gear, you can see the steering angles and the speed at which he's driving. So if your team member has the key to access the vehicle, he can take over and you can monitor everything that's happening, and you have that capability to either drive it remotely using the user interface, you can use the steering wheel, or you can let someone drive the vehicle. At this point, you may want to turn off your cameras to save on bandwidth since the mission is done. At this point, I would like to show you the editor. So first, we're going to go to clear our path, and what we will do is load just the waypoints, so with no parameters. So what we have here are the waypoints of that path without any of the parameters that we need to set up. Now we're going to go and open our editor. I'm going to make this bigger. And I'm going to load this list. So it does center around the first waypoint. We're going to zoom in slightly. So for this mission, we've chosen to drive at 9 kilometers an hour. And the way you would do that, you would go to your first waypoint and try to make it a special waypoint. You see these parameters for S and F. S stands for speed, F stands for the fence integrity flag. Right now, the values are set to 0 because you get to choose and change it according to your needs. As I said, for this mission, we will be driving the vehicle at 9 kilometers an hour. And for the time being, we will keep our flag to off because there is no fence in this area. We've accepted these changes. And now for the LiDAR properties. So I can restore the defaults. And just a quick note on the LiDAR. The blue is everything the LiDAR can see. The green is anything in the slowdown zone. And red is anything in the alert zone. So for this specific point and the rest of the mission, we will choose to change our blue Xmax value to 19. So this increases it. The look ahead value has been increased. We can also change our green X max value. So we're also increasing our slowdown zone to 16. Now we're happy with those changes. We can accept that. Looking ahead, we know we have a fence. And the one thing I'd like to mention before I move on, you see that the S and F parameters have now inherited all the values from the first waypoint that we've changed. This being said, I'll go back to the fence. And I know the fence starts roughly around here. So I'd like to set my fence flag to high. So that's 1. And I also know for the current time being, this area is slippery. So we'd like to slow down our vehicle. So we would go to 6 kilometers an hour. I would apply those changes. And in terms of our LiDAR, we don't need to make any changes at this point. So we'll just accept the previous properties that we've set. Looking ahead, we know that the fence ends about here before we do our turn. So we would go to waypoint 60, for example. And in the dynamic properties, I'm going to turn off my laser, setting this to 0. And I'd like to stay at 6 kilometers an hour. So I will apply this. For the LiDAR properties, you can make any changes based on your needs. So for example, right here, I would take the alert zone, Y max value, and I can change it to whatever value I need it to be. So I can make it bigger or I can make it smaller. For the time being, I'm going to set it to 0.6, for example. You can see that you can change whichever portion of the zoning of the LiDAR that you need. You can set only one side, you can set the other side, and so on. And that really depends on your need and the area that you're running this mission in. So we're happy with these settings, we can accept it. The last thing we did for this mission for today, we have increased our speed here. So the editor can also be used to increase your speed. It's not only to set lower speeds in areas where you need it. So we're actually going to increase our speed from the rest of the mission. And we're going to keep our fence flag to 0, which means it's off because there is no fence in this area. Lastly, since you have actually increased your speed, you'd like to have a larger slowdown zone. And what we'll do is basically go to our green zone, our X max value, and we can increase that to 18. So the faster you're going, the more space you'll need to slow down your vehicle. And we can accept this. Now we are done with the settings for the properties of this mission. If you choose to make this something that you use every day, you don't need to re-record it or make those changes every day. You can simply save the file. So for example, I can set the name to something like parameter run_winter, and you can save this file. And once you're done, you can open it. And that takes us to the beginning of our demo.